We good? Hey everybody, welcome to the Oasis Developer Breakfast. Really appreciate everybody coming out. Hopefully everybody's enjoying the pastries and the coffee. Yeah, so we've just got a little short program today. Excited to tell y'all a little bit more about Oasis, what we're doing. So yeah, to start, I'm Peter. I lead the engineering team at Oasis Labs. I've been a contributor to the Oasis network for about 5 years now, but this is actually my first time attending Consensus in person, so I'm really excited to meet developers interested in privacy and hopefully convince some of you guys to build on the Oasis network. I'm here with a handful of colleagues from both the Oasis Protocol Foundation and Oasis Labs. Please come and say hi to us either today or at our booth throughout the week. We have Mateusz, we have C, we have Matej manning the live stream. We have Will back in the back. Yeah, so we'd love to meet everybody. Yeah, so let's get started. I'm going to give just kind of an introduction of the platform that we're building for bringing privacy to Web3. So first, I'll give a brief introduction to the Oasis network for anyone who isn't already familiar with it. Then I'll talk a bit about one of the key technologies that powers our offerings for privacy-focused Web3 applications. That's the Sapphire Confidential EVM. And then I'll talk about how applications that run on any EVM chain can leverage the Sapphire Confidential EVM for the privacy-sensitive parts of their applications, and that's through the Oasis privacy layer. And then both Mateusz and C will share some cool technical demos. So the Oasis network, it's a layer 1 network. It's focused on providing scalability and support for applications that utilize on-chain privacy. The network consists of the consensus layer, which is comprised of a set of decentralized validator nodes that perform proof-of-stake consensus, and the compute layer, which is home to multiple parallel smart contract runtimes that we refer to as paratimes. So the Oasis network was actually the first blockchain to separate smart contract execution from consensus. This architecture provides a lot of potential benefits, such as the ability to scale throughput by adding more paratimes, as paratimes can process transactions in parallel. And it also allows paratimes that can be developed to suit the needs of different applications. And so one of the key technologies that enables on-chain privacy on the Oasis network is hardware-enabled trusted execution environments, or TEEs. And so the Cypher and the Sapphire paratimes both run only on nodes that support a trusted execution environment called Intel SGX. And this allows confidential transactions and state to be kept private from everyone, including the operators of the nodes themselves. And so our focus today is on how Oasis brings privacy to Web3. So now we'll dig in more to the Sapphire paratime, which is how we do that. And so the Sapphire paratime is the first and only fully confidential EVM, and it's the core building block for everything that we build to bring privacy to Web3. So what do we mean by confidential EVM? A couple of key points. And so first, for smart contracts that run on Sapphire, private variables are actually private. And so this means that the state that's managed by a smart contract can be accessed only by the smart contract itself, which is running in a trusted execution environment. And so the developer of the smart contract can choose whether and how to disclose any of this private state to users, but everything's private by default. And so the goal is to enable privacy for EVM smart contracts without compromising user experience or making transactions too expensive. And so apps that are built on Sapphire can provide a user experience that is essentially identical to any other EVM-based chain. And the developer experience is next to identical, with some added effort needed when handling confidential data. You'll get a taste of how this works from Mateusz's demo. So gas fees are very low. And Sapphire also adds some other features that are useful for applications that utilize privacy. And this includes a built-in native random number generator, and built-in support for signing and encryption. And so these are basically capabilities that we found useful for applications that people were building that need privacy. And so finally, transactions are encrypted end-to-end from the user to the runtime that's running in a T. So this can be particularly useful for applications like dApps, where you can have encrypted transactions that can prevent front-running and prevent MEB from being exploited. And so with Sapphire, we have this great advancement. It's an EVM that offers privacy. It's essentially fully compatible with the typical EVM. And we have low gas fees, but there's still this dilemma. And so for applications that are already established on other EVM chains, they have a user base there, their users have assets there. They don't want to migrate their entire application to Sapphire. So can those developers leverage on-chain privacy without having to start over on another L1? Unfortunately, we do have a solution for those developers. And so, in fact, this is the exact scenario that motivated us to build the Oasis privacy layer. And so the mission of the Oasis privacy layer is to make on-chain privacy accessible to all of Web3. And so the Oasis privacy layer has a simple goal. It's to allow developers to seamlessly add privacy to any application running on any EVM network. So to do this, there are a few important needs that we have to satisfy. So first, privacy should be customizable. And so with OPL, only the parts of the application that need privacy run on Sapphire, and the rest of the application and its assets and users stay on the home chain. To facilitate this, OPL uses cross-chain message passing bridges, and we use gas relayer to make the user experience really seamless. Also, OPL enables developers to choose how best to provide transparency in their application. And so on a traditional EVM chain, all on-chain activity is completely public. And so this is an important part of the Web3 ethos, but this can also limit the kinds of applications that we can move to Web3. And so OPL facilitates something that we refer to as productive transparency. And so as usual, all smart contract code is on-chain and verifiable, but when it comes to transactions and sensitive smart contract state, developers can choose what to make public and what to keep private. And so this is really crucial for expanding the reach of Web3 to a wider variety of applications. And so I'm just going to flash quickly a diagram of how OPL works for smart contracts and users. An important thing to note here is how the application is factored into two different sets of smart contracts. And so end users interact with the smart contract on the application's home network as usual, and they also interact with privacy-enabled smart contracts that are running on Sapphire. But they can do this with the help of a gas relayer, which means they're not required to go out and get the gas token for the Oasis network, which is ROSE. And so this is really crucial for enabling that seamless end-user experience. And yeah, we can dig more into the details later, and you'll see with Mateus and C's demos a little bit more the technical details there. So just before I conclude, I'd like to just give you a little bit of an idea of the kinds of use cases that we're excited to see developers use Opal for. So there are a bunch of different applications that can benefit from on-chain privacy via OPL. I'll touch on just a few of them here. For DAOs, allowing members to cast their ballots in secret can facilitate better governance. It can prevent votes from being influenced or manipulated by outside factors during the voting period. And still, for transparency, votes can optionally be made public after the voting period is complete. And so this is a really cool example of a use case that OPL can really help with. We think that on-chain privacy has the potential to power a lot of advances in the gaming space, and so secret state is a huge part of many games. So the order of the cards in a deck, or the cards in another player's hand, or a fog of war, for example, solution to a puzzle. And so without on-chain privacy, all of this state has to be maintained off-chain, and so you don't get to benefit from the trustlessness and the integrity guarantees that a blockchain can provide. But with Opal, developers can bring the logic that manages secret game state on-chain and really enjoy all of the benefits of being backed by a blockchain. Decentralized identity, or DID, this is really just an expression of the core concept of Web3, that users should be able to own and control their own identity without the need for a centralized authority. But when we think about the bits of information that might be useful for a user to be able to prove to an application, to be able to participate, a lot of this data is very sensitive and not the kind of thing that users would want to publicize on chain. For example, maybe your age, the country you live in, information about your creditworthiness. And with OPL, we can actually bring all this information on-chain and maintain it confidentially, and users can choose which bits of information to disclose to which applications. And so this really gives us kind of the best of both worlds there. In the NFT space, OPL makes it easy to add private attributes and unlockables to NFTs, and so there's obviously a lot of interest right now in bringing more features and more utilities for NFTs. We think this is a great way to do it. And then finally, in DeFi, OPL makes it possible to build an MEV-resistant DEX pretty easily, and so end-to-end encrypted transactions and selectively encrypted state make it really easy to protect end users from being front-run. That's just kind of a high-level overview of the privacy-enabling technologies we're building at Oasis. I will now hand it over to Mateusz for a deeper dive into Sapphire.
Is it possible to ask a question?
Sure. Maybe you can take a question or two while Mateusz is setting up. Go for it. Do you want to get on the mic there?
Does this work? Yes, so I don't think it works. But anyway, I try to raise the voice. I think for DeFi, MEV is a really... Sorry?
It's live one.
Oh, okay. So really for DeFi to be really successful, the front running and the MEV is a big issue. Mm-hmm. If you can resolve this, it certainly is good. There is a issue still, like even you can encrypt using ZKP, you have the prover which is centralized. It can front run you, right? Yep. Is that something that you guys thinking to solve this issue as well? Or?
Yeah, so the technology that Sapphire uses for privacy is these hardware-enabled trusted execution environments, and so the runtime itself runs in this enclave. The memory is encrypted and all state is encrypted, so it's actually not possible for anyone but the actual runtime code itself to decrypt the transaction and run it. And so we don't, unless someone breaks the trusted execution environment, there's not an opportunity to front run users' trades in that way.
Okay, makes sense. Unless you encode that you bought into the TE.
So your bot, the encryption keys are only released to the particular enclave that defines that runtime, and so your bot would not be able to get access to the encryption keys and decrypt transactions.
Like you initially deploy and you bought.
Fair enough. And so, all the code is open source and controlled by network governance as well. So there's a lot of transparency there.
Thank you.
It's a good point. Cool. I'll hand it over to Mateusz, and let me.
Screen on for this thing. Just put it.
So let's dive into the Oasis Sapphire. So the first question, can you raise your hands, anyone who wrote a smart contract? All right, and how many of you wrote a smart contract on Oasis Sapphire? Great. Okay. Yeah, welcome. As Peter mentioned, the Oasis Sapphire is our fully confidential paradigm. So what does this mean? This means that the contract state is accessible only by the EVM running inside the trusted execution environment. So basically you cannot read or write to the contract state if you're not inside this confidential EVM. This brings plate of new opportunities, because if you, as an external observer, look at the blockchain content, even if you try to download the contract state, it's encrypted and you can't do anything without it, right? So another part we need to take care of is the communication between the client, for example, your MetaMask running in your browser, or Truffle uses this HD wallet instance, or the Ethers, the communication between those and the EVM. And we use a special end-to-end encryption using ephemeral keys generated by the paradigm to achieve this, right? And we are thinking on how to deliver this to our developers, and we tried to simplify it as possible. So basically we ended up with two NPM packages. The first one is the Sapphire Paradigm package, which basically wraps your existing signer, and if you then try to send a transaction, or you try to broadcast a transaction, or do the contract call, this will be automatically signed by the Ethereum key of your account and also encrypted. The second package is the Sapphire Contracts package. So the Oasis Sapphire includes a number of pretty cool precompiles. Peter already mentioned the random number generator. So anyone trying to generate a random number on Ethereum chain probably noticed that this is practically impossible, because the smart contract running inside the EVM can only get data from on-chain, and because all the on-chain stuff is public, then you can't get any entropy to generate a quality random number from, right? So here we actually have this secret key inside the trusted execution environment of the contract, and basically you can get the entropy from there and generate good random numbers. So we wrapped that precompile inside the Sapphire contracts, so we can just call the random and the number of bytes you want to get, or the number of random bytes you want to generate, and potentially add some other seed, and you will get completely random data. Another precompile is also if you want to generate, generating random numbers now gives you a possibility to generate a new key pair, right? On-chain, without any third-party access, right? And we made a library which contains these helpers to generate a key pair, to also encrypt and decrypt messages, to generate a shared secret from a key pair using our Oasis wrapper. And this is pretty useful because the events are still public on Sapphire, the Ethereum events. And you couldn't communicate with your client secretly without encrypting the message inside the Ethereum event otherwise. Right? So this is now all possible on Sapphire, and it's already on mainnet, and you can use it in production. Right, so another, the last resource I'd like to point out is our documentation. This is a pretty comprehensive material because it focuses first on the general audience. So here you will learn how to manage your tokens, because paradigms are kind of sub-chains running on our network, and you cannot use your tokens directly inside the Sapphire or Emerald paradigm. You need to first bring it to consensus and then deposit those into your paradigm and then use it, and then when you want to move it, for example, to exchange, you need to withdraw it back to consensus layer and move it from there, right? So this is all covered here. For the node operators, we have a special section here. So if you're running, if you're in the full node validator or just running a client node, because you want to assure that it's really private, the instructions are all here. And then we have 3 sections for developers. One is if you're a dApp developer, this covers material for all the 3 paradigms we currently have on production. So the Emerald is the non-confidential EVM, Sapphire is a confidential EVM, and the Cypher is a special paradigm which uses our own WASM language, and usually constructs are written in Rust programming language in this case. So the reason why we did this is because the Solidity language doesn't provide or is not really tailored towards the confidentiality, and we were thinking if it would be more appropriate if we design our own tooling for the complete stack from the programming language upwards. And yeah, the Cypher paradigm is an alternative if you're not keen to EVM development. And there is also material for how to build your own paradigm. So currently there are 3 paradigms in production, but no one prevents you. I mean, it's a distributed network, so no one prevents you if you want to make up a new paradigm all by yourself and register it and to run your compute nodes on it. And then there is also some material for if you want to contribute back to the Oasis core. Right. Okay. Demo. So we prepared a special dApp exclusive for this Consensus 2023. It's called the Oasis Swag. So the idea is if you want to have some of the Oasis Swag, you would spin the Wheel of Fortune, and the one which you draw is the swag you then obtain, right? And why is this so nice? Because it uses, well, the on-chain random number generator I talked about previously. So yeah, you can go ahead and try it. I will try it here. You will need your MetaMask wallet because it combines this secret key with your MetaMask address, and then combines that and then generates the random number out of it and which swag do you earn. So let's go ahead and try it. So you connect your wallet. Okay. Tap to spin, and let's see. So okay, here's my MetaMask. Right, and this is a contract call. So in contrast to the ordinary EVM transaction, the contract calls here are also signed, because this is the only way you can assure that the message sender is really the author of the transaction, the author of the contract call. If you recall, in EVM, there's a possibility where you can change the message sender and change identity to something else, and then, for example, call the balance off to get the token balance of your account, for example. Well, in this case, we prevented this, and we require that any contract call needs to be signed by your Ethereum key. And this is what MetaMask is currently proposing. So the spinning the wheel is just a simple contract call. It doesn't require any tokens, but it requires that you sign the message. Okay, so let's go ahead and sign it. Yay! So I won a fan. Cool. And to top it all, there's also a way, if you want to add this fan as an NFT to your private wallet collection. So yeah, let's add it. And if everything goes well, this is also a secured encrypted transaction currently being broadcast, so let's hope this works. Okay, it seems to work. All right, so NFT claimed. So since we're not the officially registered contract at the OpenSea, let's add NFT manually to our wallet. And okay, so this is my private fan NFT. And then you can come up to us or to our booth or here, and you can claim your swag. Yeah. Cool. Now, what I really want to, this is just a showcase. What I really wanted to show you is how this contract works under the hood, right? So if you go to our GitHub, there's a link in the top right corner to access it. The source is fully available. If you go to our contract page, let's analyze this a bit. Okay. Perhaps I should just zoom in a bit more. So you will notice how easy and straightforward it is to use Sapphire in practice. From the Sapphire contract sampling package, you need to include our Sapphire sol file. Then, because this contract is also ERC 721 compatible, you need to include the OpenZeppelin wrappers for this. Right, and then here we define the swag. We got the name and the image. And here are the private variables of this contract, right? So here's the list of all swag types, the probabilities of how often the swag will get elected, right, drawn. And then this field is specific to, let me zoom in a bit, is special to our Oasis Sapphire because it contains a randomly generated mask, and that mask gets XORed with your address, right? And when is this mask generated? It's generated when you construct the smart contract, when you deploy it for the first time. And it calls this random bytes function, which generates 32 bytes randomly, completely on-chain. Okay? And then if you go further down, when we draw the swag, actually, yeah, here it is. How do we use that mask then? Well, we combine the mask with the message sender, and we get inside this probability gradient, we get where does this map to, right? And then we draw a swag. Another line which is important is this one. Here we prevent any non-signed contract calls. So if you remember in EVM, in the yellow paper, I think it's mentioned that the message sender will never ever be zero. It will always be filled. Well, here we expose that, and we set the Sapphire sets this field to zero if the transaction is not signed. This means if you send an ordinary EVM non-encoded, non-signed, non-encrypted transaction, this message sender will be set to zero. Okay? And here we basically require that the user must have this MetaMask wrapper installed and that the contract is signed, right? Okay, and that's it. The rest of the code is basically just ordinary Solidity code.
So how random it is?
That's a good question. So it relies on.
Is this using the ing function, or is it just a mass random?
No, it's a masked random, but it uses the secret, the state encryption key uses as an entropy and then adds some nonce on top of that. And this is sufficient basically, because if you access the contract state key, then I mean you're hacked anyway, and you can basically use that for the entropy, and whichever nonce you add to that, it's random enough for the seed. That's it. Okay, so if we have another minute, I would just add another demo. So one is this swag demo, which you can which you are invited to spin the wheel and get a swag. And there's another demo we also prepared. I will give you this for your homework. This is a simple quiz. The contract contains questions and expected answers. And if you get you can use a special coupon, which are sticked at the back of the Oasis flyers here. You will get a unique question, and if you provide the correct answer, you will then get an access to the reward in rows. So basically, you will get a private key on the Oasis mainnet, which you can then claim the reward from. Okay? So the instructions are here. The link is on this flyer, so you can check it out, and if you do your homework, you can claim your reward. And I think if you have any questions, don't hesitate to join us at the dApps Sapphire channel on our Discord, and we'll help you out and get your reward, okay? Cool, this is it for me. Any more questions? And now I will hand over to C for OPL in action.
know, to a question earlier, but I love asking questions. So I think a lot of people raise their hand when they said they have developed a smart contract application before. Was that right? Like, could I just get you to raise your hand again? And so I think if you recall the earlier parts of the presentation, Peter mentioned how important it was for us to focus on making it easier for you to have, say, your existing stack of smart contract applications on Polygon, on ETH network, on whichever networks you're on. But you can add this privacy portion and interact with everything all together by deploying this single smart contract on the Oasis network. So we have made a very basic tutorial to help people do that. And this is a preview of said tutorial. And pending my manager's approval, which I don't have yet, but let's take a look. So really, if you can work through a hard hat, you can, yeah. You have to speak louder. Oh, I have to speak louder? Okay.
This is just for the stream.
Okay, all right.
Your theater voice.
My theater voice. Okay, so yeah, if you can work with hard hat and deploy a basic hello world contract, smart contract application to Ethereum, you can develop on OPL. I promise. And this tutorial is going to show you how. So very simple, very straightforward hard hat setup instructions. And we just make a new hard hat project. And the only thing that's really special or different are how you would use the OPL libraries to write your smart contract just a little bit differently. So you can take a look here that this would be your basic DAO smart contract. It holds a bunch of proposals or basically like ready for a ballot to vote on. And that's it. Very small smart contract, pretty straightforward. And then highlighted here are the differences of what you would have to write to make it work with the privacy layer. So 1, 2, 3, 4, 5 lines, and then a message, or this function, which is how it interacts with the privacy layer. So I think I would just suggest to think of it as it's basically a callback for messages coming back from the other chain. And yeah. And then similarly, you would just write your normal smart contract for the privacy layer. And so whatever holds secrets goes on the privacy layer as part of this enclave. And yeah, that's it. So please come to our booth, and then I'm happy to walk through this tutorial with you. It'll take like 5 minutes, promise, tops. And for how it works, we can just show it over here. Yep. So let's say you have a very, very basic DAO, and it's just asking a bunch of questions. In this case, we really like food, colors, coffee, tea, kolaches. And so we can click on this poll that Imitation made over here. So you'll notice that we switched over to the Sapphire network because the voting happens within the privacy layer to conceal your votes. And let's say whatever this Ital Cream Cafe is what we want. And great, I never had it. So we'll vote and do the normal MetaMask thing. And yeah, that's it. We can go back and I think you'll have, so I think Mitesh actually has to be one to close this ballot, but let me just try it because what's a live demo without a little bit of risk? So now I think if we, so this does take a little bit of a second because the message that goes to the privacy layer, right, then has to go all the way across a bridge, and then for it to interact with the DAO smart contract, which is deployed on a different blockchain network. So that part is a little bit unavoidable for just any applications that you're building cross-chain. But the privacy layer abstracts that and makes it so that you don't have to think about it. So let's go back and see if that worked. And so we'll switch back. And let me refresh this page just in case my JS view wasn't right. And you'll come down all the way here and then see that the coffee poll has closed with an outcome. And so, yeah, that's it. Really, really happy to walk you through.
This one's correct, yeah.
Oh, okay. All right. Okay, it's your favorite. Yeah, so thank you for checking out these demos. Our tutorial instructions will be live as soon as my manager in the back approves them. And but I'm happy to talk code. We're happy to give you whatever support you would like. And yes.
So if I'm a user on, say, Binance Smart Chain or something else,
Yeah.
and I voted in this, did MetaMask automatically add Sapphire? Did I
Yes,
switch
that is a great question. So in this particular case, for the case of this demo, I did load up my testing account with test tokens on both networks. We do have works for a gas station network, so the idea is then that no, this is all abstracted away from the user, and so.
But both the gas relayer and the message relayer are still in the works, right?
So we're testing out the message. We're working with two message relayers. We're testing out and confirming our mainnet deployments of the message relayer. We're still working on the gas relayer, if that's the. But I'm an engineer, so take that with a small grain of salt. I defer that question to our BD and partnership person standing next to you. Well. Yeah, if you have any more questions, oh, sure.
Does it check, privacy for what you voted, and also the sender address, as well as the contract? Is there privacy level, like just what you voted, or also who voted? And which contract?
Yeah, so great question. So in this particular demo smart contract I wrote, you'll see, of course, that, let's see, testnet, explore. So, this is let me grab my address. Okay. All right. So this is my address, F209. And you'll see this is the most recent transaction transaction contract call I made. And so it interacted with the secret smart contract that's holding all the secret state, right? So it's literally a ballot box visualized on a smart chain, on a smart contract. And then so this particular data itself You'll see that from hex, CBOR. So this is actually part of the encryption that Peter was talking about earlier. So you'll see that there is a private key encrypting all of this data, which is down here. And so the enclave itself that's running this computation has the private key to actually decrypt this information, and but otherwise unencrypted. Great question. Okay, yeah, love to chat with y'all further after this. Thank you so much.